Welcome back to the sixth section of Chapter 7. In this section, we are going to be continuing factoring these trinomials. The difference is now we have a number in front of the x squared. So we're going to see a few different things we can do to deal with that number. So our learning targets, I can factor polynomials in the form ax squared plus bx plus c. Last time it was just x squared plus bx plus c. So what are we going to do? The very first thing is factor out the common factor. Anytime you're factoring, it doesn't matter how big something is, doesn't matter what kind of thing something is. Step one is always factor out the common factor. If we had a 7-nomial, the very first step, factor out the common factor. If we had an exponential function we were factoring, factor out the common factor. That is always, always, always step one. Then once you've done that, then you see what else you have to do. So, for instance, if we have 3x cubed plus 15x squared minus 18x, common factor. Well, we can divide each of these numbers by 3. So we're going to have a 3, and each of them has at least one x in it. So we can factor 3x out. What does that leave us? Well, 3x times what equals 3x cubed? That's x squared. Plus 3 times 5 equals 15. And we need one more x. Minus 3 times 6 equals 18. And we already have the x. So that's what we were doing right at the beginning of this whole factoring thing, was factoring out that common factor. Now that 3x is going to sit there, and we can look at what is in those parentheses. So we have 3x, and this is what we were doing last time. So what times what equals x squared? Well, that's x times x. Now we need two things that multiply to give us -6, so that'll be a plus and a minus, and adds to give us 5. Well, what multiplies to give us -6? A 2 and a 3, but one of them has to be plus, one of them has to be minus. So when we add a 2 and a -3, or a -2 and +3, we're going to get a 1 or a -1. What else can multiply to give us that 6? A 6 and a 1. Can we make one of them negative and then add them together to get a 5? Yep. So we could have a +6 minus 1. So if we multiply this, we'd have x squared minus x plus 6x is plus 5x minus 6. And so this is the factored form. So this started out by factoring out a common factor, and then we just did what we did in the last section, that whole last week. So let's give it a try. Both of these are going to be done the same way. We'll be able to factor something out, and then we'll be able to factor what's left using what we already know how to do. So go ahead and pause me for a second and give these a shot. All right, let's take a look. So this first one, we have a 5. All of these are divisible by 5, so we can factor out a 5. And then they don't all have an x, so we can't factor out an x. So we factor out a 5, we'll end up with x squared minus 5 times 7 equals 35, so we have 7x, plus 5 times 10 equals 50. Now we need two things that multiply to give us 10, that add to give us -7. So being that they multiply to give us a positive, they have to be the same sign. They add to give us a negative, means they both have to be negative. So we'll have an x minus something, x minus something. Then what times what equals 10? 5 times 2. Do 5 times 2 add up to give us 7? Sure do. So we can check. X times x is x squared, minus 2x, minus 5x is minus 7x, -5 times -2 is 10. So that's factored. If you haven't tried this third one yet, or if you need to make adjustments, go ahead and try that one. And if you're ready, we can continue now. So what do they both have in common? Or what do they all have in common? We can divide all of them by a 6. And we can divide an x. They all have an x in common. What does that leave us with? Well, 6 times 1 is 6, so we need an x squared. 6 times 5 is 30 with an extra x. And 6 times 4 is 24, and we already have the x. So we'll have a 6x, and then x, and an x. Everything's positive, so it'll be x plus something, x plus something. What times what equals 4? That adds to give us 5. Well, 4 is 2 times 2. That doesn't add up to 5, though. 4 is also 4 times 1. So we have 4 and a 1. So now x squared plus x plus 4x is plus 5x. And then 4 times 1 is 4. So we have 6x times x plus 4 times x plus 1. So step 1 is factor out the common factor. And that is, again, true in every single situation. The ones that we'll be looking at now, they don't have a common factor. So we can't factor out a common factor. The ones that we just did, we factored out, then we were able to factor them using what we already know. It's possible that we'll factor out a common factor and we'll get something that looks like this, and we'll have to use one of these techniques to factor it. So we have a couple different methods of factoring when we have this value in front of the x squared. The first one we're going to look at is called factoring by grouping. So in the last section, and in what we just did, we needed two numbers that multiplied to give us the 4 and added to give us an 11. Why was that? Because when we had x times x, and then plus, we'll go a and plus b, we multiplied, we got x squared plus bx plus ax plus ab. We'd combine these two terms, we had a plus b, and we multiplied these terms to get a times b. Well, now that we have a number in front of the x squared, there's going to be values here in at least one of those places, because in order to get 6x squared, we could have a 6x times an x, or we could have a 2x times a 3x. And so there's going to be something there, and those numbers will multiply to the b and to the a. So factoring by grouping is one way of looking at this. So now instead of looking at what numbers multiply to give us 4, we have to multiply these two together. 6 times 4 is 24. So now we need two things that multiply to give us 24, but add to give us 11. So we need multiply to give us 24, add to give us 11. So we have 6 times 4, but 6 plus 4 is not 11. What else could multiply to give us 24? 12 times 2, but 12 plus 2 is not 11. 8 times 3. Well, 8 plus 3 is 11. So we're going to split this 11x into an 8x and a 3x. So we'll have 6x squared plus 8x plus 3x plus 4. And now we're going to group these. Now if I group them right like they are, they don't really have all that much in common. I mean, they have a little bit. Well, yeah, let's group them right like they are first. So we're going to look at these two, and we're going to look at those two together. Then I'll switch the grouping around so that we can see what happens there. Now that we have these groups, we can factor out what they have in common. So the 6x squared plus 8x, what can we divide both 6 and 8 by? A 2, and they both have an x. What's left? 2 times 3 equals 6, and we need an x, plus 2 times 4 equals 8, and we already have the x, plus 3x plus 4. That doesn't have anything in common, so we can't do anything with it. I'm going to factor out a 1, because you can multiply 1 to anything, and that's really just a placeholder here, because we're going to see something. 3x plus 4. Now we have two things. Again, we have this 2x times 3x plus 4, and we have a 1 times 3x plus 4. We can factor out what these have in common. What do these have in common? A 3x plus 4. So when we factor out the 3x plus 4, what's left in this first group? A 2x. And what's left in the second group is a 1. That's factored. 3x plus 4 times 2x plus 1. If we would have switched this order around, so I'm gonna go back to here. We have 6x squared plus 3x plus 8x plus 4. We're still going to group them the same. Factor out 6x squared plus 3x. Those have a 3x in common, leaving 2x, because 3 times 2 is 6, plus 1. We have to have that placeholder there. Plus, now the 8x and the 4 both have a 4 in common, leaving us with 2x plus 1. Now, hey, look, both of them have a 2x plus 1, so those can factor out. 2x plus 1. And then what's left? A 3x plus 4. 3x plus 4. Notice that these two things are the same. It's just we ended up getting them in the other order. So it doesn't matter what order you put these numbers in, it'll still come out to be the same. So that's factoring by grouping. Again, we started out by multiplying the a and the c. So this number in the beginning and this number at the end together. And then we found what two numbers multiply to give us that adds to give us the middle number. So it's similar to what we did. And then we split it up and factor by grouping. And factoring by grouping is a skill that definitely comes in handy later on as well. So if you think you're ready, we have a couple more problems. Give them a shot. If you want to wait till after we do this next one so you can see another example first, you can. But I'd recommend giving it a shot. I mean, there's no harm in trying. And then you can see where it is that you're not making a connection, if that's the case. So you can go ahead and pause me and then play me again when you're ready. All right, so let's look. We have to go 10 times 3 is going to give us 30. So we need to multiply to get 30 and add to get 17. Well, what multiplies to get 30? Well, 10 times 3. I mean, that's how we got it. But 10 plus 3 is not 17. What else multiplies to get 30? 15 times 2. And 15 plus 2 is 17. So that works. So we'll take the 10x squared plus 15x plus 2x, that's how we're splitting up the 17x, plus 3. And again, you could go 15x plus 2x or 2x plus 15x. It does not matter. We're going to group them. And now 10x squared plus 15x, what do they have in common? They can both be divided by 5. And they both have an x. So 5 times 2 equals 10. We need another x. Plus 5 times 3 equals 15. We have our x. plus. 2x plus 3 doesn't have anything in common, but notice that's what we have here already. So we'll go 1 times 2x plus 3. All right, now they both have a 2x plus 3. And then times what's left? A 5x plus 1. And so by grouping, we're able to factor these. All right, let's try the next one if you haven't already, or if you saw something, like you did something wrong in this one, maybe you need to go and check the next one, see what you did. When you're ready, you can play me again, we can continue. All right, well, so this is a negative here, so we're going to have a positive and a negative, because when we multiply 2 times 21, we'll have a negative 42. So we have to multiply to a negative 42, and we're going to have to add to a 1. Well, what multiplies to give us negative 42? A 2 and a 21 do. Are those going to add, or being that one's positive, one's negative, are they going to subtract to get us 1? No, not even close. We're going to need two numbers that are right next to each other, because that's what's going to subtract get us 1, right? Like 3 and 4, 5 and 6. So what two numbers that are next to each other multiply to give us 42? 6 times 7. And we can make this to make it a 1, that would be 7 minus 6. So that 6 would be negative. So when we split this up, we can go 2x squared plus 7x minus 6x. I'm going to go minus 6, because that's going to go with the 2x squared better. So we'll go minus 6x plus 7x minus 21. And we can split this up. What can come out of both of these? They both have a 2 in common. They both have an x, leaving us with x minus 3 plus, these both have a 7 in common, leaving us with x minus 3. Okay, these two things have an x minus 3 in common. And what's left? 2x plus 7. So that's factoring by grouping. On this one, if we did happen to switch that around to get 2x squared plus 7x minus 6x minus 21, we can still do this. We'd have to split it here and here. The first one would have an x in common, so you'd have x times 2x plus 7. This next one would have a negative 3 in common, which would give us 2x plus 7. And then we can factor out the 2x plus 7, the x minus 3, to get right back to where we started out, or where we ended up actually in that previous one. So that's factoring by grouping. This works. There's another method called factoring using substitution. There's also the method I use, which is just logic your way through it, involves trial and error. So factoring using substitution, we're going to multiply by that number. We're going to multiply everything by that number. So we multiply by 3. And so what happens in this first one, we have 3 times 3. So we have, let's just say 9x squared minus, I'm going to say 2, I'm not going to multiply this one out. 2 times 3x minus 8 times 3. So now this 9x squared, 9 is 3 squared, because we just multiplied by that. So this we could write as 3x squared. So we put that 3 inside, minus 2 times 3x minus 24. So this is something squared minus 2 times something minus 24. To help out here, we could give, instead of saying something, we could give it a name. We could call it A, but we already kind of use A because we have ax squared minus bx plus c. So we won't want to use A, B, or C. We can use P. We're not using P, but you could use anything you want. So this we could rewrite as P squared minus 2 times P minus 24. And now this is going to factor just like what we've been factoring, because there's no number in front of that squared anymore. So this could be a P and a P. Now we need two numbers that multiply to give us negative 24, add to give us negative 2. How about 6 and 4? They multiply. And if we go minus 6 plus 4, we have P times P is P squared, plus 4P minus 6P is minus 2P. Negative 6 times 4 is negative 24. So we have P minus 6 times P plus 4, which is great, except we weren't dealing with P's. So we replace the 3x with P. We need to put that 3x back. 3x minus 6 times 3x plus 4. Now, one of these two we should be able to factor, possibly both. But in this first one, hey, these are both divisible by 3. We can factor out a 3, which leaves us with an x minus 2, then the 3x plus 4. Why is it important to factor out that 3? Because way up here we multiplied by 3. This is that where we multiplied by 3. So we need to get rid of it. We need to divide by that 3 that we multiplied by. So the answer here ends up being just x minus 2 times 3x plus 4, which if we multiplied this, x times 3x is 3x squared. Then we have 4x minus 6x is minus 2x, and then negative 2 times 4 is negative 8. And so by multiplying this out, we get back to how we started. Now, could you have done this using substitution? Yes. Or using grouping? Yes. Could you have done the grouping using substitution? Also, yes. Different methods. Some methods work better for some people. Some methods work better for some problems. So let's give this a shot. See what it is. So again, multiply by that first number. Try it using substitution. Multiply by the first number, factor, and then factor out that number that you multiply by. Go ahead, give these guys a shot. Come back and play me again when you get done, and we'll check over them. All right, let's take a look. Let's multiply this one by 2. So we get 2 times 2x squared. So that's 4x squared, or 2x squared, minus 2x minus 12. So if we change this, we could have p squared minus p minus 12, which will factor. So we'll have a p and a p. Then what's going to multiply to give us 12 and add to give us negative 1? A 3 and a 4. And being that we need it negative, that'll be a minus 4 plus 3, because we get p squared plus 3p minus 4p is minus p, and then negative 4 times 3 is negative 12. We need to plug that 2x back in because we're not dealing with p's. So 2x minus 4, 2x plus 3. And then this first one we can factor out that 2, leaving us with an x minus 2 times 2x plus 3. And then that 2 is the one that we multiplied by to begin with. So we need to just divide by that. essentially get rid of it to leave us with x minus 2 times 2x plus 3. Right? How'd that one work out? Right? If you haven't done this one yet, try this one. Again, you're going to multiply by 10. So you'll end up with a 10x squared. All right. So when we multiply by the 10, it's going to leave us with a 10x squared plus 3 times 10x minus 1 times 10 is 10. We can replace it with p's. So p squared plus 3p minus 10. And again, the p is just a placeholder because having the 10x's in there, it just makes it more complicated. This is something simpler to look at. Now we need two numbers that multiply to give us negative 10 and add to give us 3. Well, what multiplies to give us a 10? 5 and 2. And a plus 5 minus 2 will add to give us 3. So here we have p squared minus 2p plus 5p is plus 3p. And then 5 times negative 2 is negative 10. All right, let's replace the p's with the 10x's. So we'll have 10x plus 5, 10x minus 2. And so now, this first one, we can factor out a 5. Leaves us with 2x plus 1. And the second one, they both have a 2 in common, so we can factor out a 2. Leaves us with 5x minus 1. 5 times 2 is 10. That's that 10. It was split up between the two of them this time. And so, when we divide that 10 back that we multiplied to, we end up with just the 2x plus 1 times 5x minus 1. So that would be factoring using substitution. So we have using substitution, we have using grouping. Those are how we can get these. Before you do either of them, you'd always want to factor out what they have in common. That is always step 1. And then you factor. So you can use either of these two methods. Pick one, the one that makes more sense to you, and work with that one. Focus on that one. Make sure you get that one really good. And then once you get that well, if you would like to look at the other method, try the other method. But it's important you get at least one of the two methods so that you can use it effectively. So I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.